class of 2018 at Vinci Science High School. During my time at Da Vinci, I've grown in my overall work ethic, how much effort I put into my assignments, and also how I can manage my time. Today, I'll be telling you about my English, ID, and geometry presentations. First and foremost, I'll start off with ID with a focus on case number 2. This means I'm able to draw oblique and isometric shapes along with any given shape in a multi-view sketch. However, my main focus will be on drawing shapes in general and also my basic comprehension between drawing, which is using a ruler and object lines and construction lines, and sketching, which is drawing freehandedly. First, I'll talk about oblique shapes. Oblique shapes are usually drawn at a 90-degree angle and contain a three-dimensional view. There are two types of oblique shapes. There's a cavalier shape and a cabinet shape. A cavalier shape is a shape that extends back at its full length. However, a cabinet shape is the exact same shape that extends back at half its length while still maintaining the actual form of the original shape. An example of oblique shapes would be the ones that are found in my engineering notebook, as you can see here. The next type of shape that I'll be covering is isometric shapes. Isometric shapes are usually drawn at a single plane at their full scale and are also three-dimensional. They're drawn on special isometric paper and contain the front, right, and top views. Most of the lines drawn on the sketch are parallel to each other, and they're also drawn at a 30-degree horizontal edge if you follow the pattern of the isometric paper. One example of an isometric shape would be the one that is found in my technical drawing test up there, and the second example that I provided is the isometric sketches for my puzzle cube project. The last type of sketch I will be covering is a multi-view sketch. A multi-view sketch is a sketch of your shape with only the front, right, and top faces, and it is the only sketch that can be dimensioned. If it's the only sketch that can be dimensioned, then that must mean that dimension and extension lines will be very handy when you're showing this to an engineer. And if you want to highlight a certain part of your shape or also describe the diameter of a hole in your part, then you can use the leader lines. An application of EKS number 2 would be my puzzle cube project. As you can see, I took isometric drawings and I made those into physical puzzle cube pieces using wood glue and wooden cubes, and after making all my pieces individually, I put them in a 3x3x3 puzzle cube, as you can see here, as my finished product. This also concludes my ID presentation, and I will now move on to geometry. For geometry, I'll be focusing on EKS number 5, which is right triangles. This means I'm able to solve any right triangle problem with my knowledge of the use of the Pythagorean theorem. For example, in question number 3 on chapter 3 quiz A, we're given the task of finding the hypotenuse for a triangle with only one known side and a given area of 24 inches squared. In order to do this EKS, you must know how to use the Pythagorean theorem, how to find the hypotenuse for a triangle, and also what the area formula is. The following smaller skills that you need to do would be how to distinguish right triangles, so how to know that a right triangle is a right triangle in order to use the Pythagorean theorem, how to use inverse operations, how to approximate your square root for your hypotenuse, and also how to find missing sides of a triangle. For example, in question number 3 on chapter 3 quiz A, I wrote the incorrect answer by saying that 1/2 a times b equals 4b. I assumed that 4b was equal to one of the multiple choice answers, which led me to mark the wrong answer. I also didn't follow the directions because I didn't find the hypotenuse, or length of QR in this case. However, in my corrected version, I wrote 24 equals 1/2 a times h, and I actually used the given formula. This gave me 24 equals 4h, and I divided both sides by 4 using inverse operations to find out what the height was. This tells me that the height was equal to 6 units. Now knowing the height and the base of each triangle, I then used my knowledge of the Pythagorean theorem to find out that 6 squared plus 8 squared equals x squared, or that 36 plus 64 is equal to the square root of x. We all know that 36 plus 64 is the square root of 100, and the square root of 100 is 10. And this leads me to mark the right answer, which is 10 units, or the hypotenuse of this triangle. An application of EKS number 5 would be this missing value problem that I've created by myself. As you can see, I drew a right triangle with only the hypotenuse and the base available, and we needed to find the height, or the missing side in this case. I wrote 2 squared plus x squared is equal to 6 squared, which is 4 plus x equals 36. I subtracted both sides by 4 to isolate the x variable, and I found out that x equals the square root of 32. The square root of 32 is approximately 5.65 units, which means that if I plug this in, which is 2 squared plus 5.65 squared plus 6 must equal 6 squared, which tells me that x is equal to 5.65 units. This concludes my geometry presentation, and I will now move on to English. For English, I'll be focusing on 2 EKSs, which is EKS number 4 and EKS number 9. EKS number 4 is advanced vocabulary and shows that I can take in and comprehend vocabulary taken from literature that is read in class. EKS number 9 tells me that I'm able to do MLA formatting on my essays and write correct headers on my paper. For example, in my Can You Roll vocabulary chart on chapters 1 through 3, we were given the task of finding the definition, providing examples and non-examples for each word, and also creating a drawing or an image in order to help us remember each word. In order to do this EKS, you must know how to define each word, how to understand the context that the word is in, how to use the MLA formatting to write the header on your handout, and also how to provide very good examples and non-examples to help you remember each word. The following smaller skills that you need to do would be how to analyze the literature that your word is in, how to use Google search tools to find your definition or an idea for an image that you can put on your paper, and also how to memorize each word and apply it into your speech daily and effectively. One piece of evidence would be my Can You Row chapters 1 through 3 vocabulary chart. As you can see, I provided a very big example and non-example, and it didn't really help me remember the word. And when it came to words with more than one definition, I also put different definitions than the one that was originally meant to be in the word. This really threw me off when I was studying for the test. However, I wanted to improve upon this, and in order to improve, I made sure that my definition was matching the context. I also used very specific examples and non-examples, like in my example I provided for the word warped, I used a very specific example by saying distorted photo. This also served as my image for the word, which helped me remember. I showed mastery in MLA formatting for the header for my paper. I wrote it in the correct format, which was the name, the teacher, the class, and the date in the format of the day, the month, and the year. I also showed mastery from my absolutely true essay, as you can see from my college vignette. I made sure that the margins were 1 inch, and I made sure that all my text on my paper, including my header, was double spaced. I also put a page number and my last name on the corner, and I also made sure that my title was centered. This demonstrates my mastery in EKS number 9. An application of EKS number 4 and number 9 would be my Can You Roll vocabulary quiz on chapters 1 through 6. I wrote complete sentences for each word, and I also matched the correct definition for each word, which alone has given me a mastery score of 4. I also wrote the correct heading in the MLA format on my paper. This quiz strengthened my memory for each word and gave me a better glimpse or comprehension of how I can use these words in the future. This also concludes my English presentation, and I will now move on to my reflection. For my reflection, I will be focusing on the habit of mind, which is quality. At the beginning of the semester, I didn't come to office hours, and I rushed to get my work done in order to have free time. This made me put in no effort whatsoever in all my work and made my grades go down. However, in order to improve upon this, I took most of my time and I put in lots of effort into my work in order to raise my grade. And I also started coming to office hours and asking any thought-provoking questions on things that I didn't understand in order to raise my grade so I fully understand it. One piece of evidence for quality would be my engineering notebook isometric sketches. I put lots of effort into drawing straight lines using correct shading for each sketch and also correctly using isometric paper, as you can see here. If you look at the rubric that is provided on the slide, this has earned me a mastery score of 4 for each page that my sketches were on. For my SLC goals, my original goal was to improve all of my grades overall because some of them were dropping, and then to improve my study methods in order to get these good grades. However, although some of my grades have been raised to an A, some of them still remain the same, and that means that I didn't meet my goal yet. However, in order to meet my goal, I will continue to ask for help, coming to office hours every day in order to make sure that I understand something, and also doing practice problems if necessary to make sure that I understand the concept fully. This concludes my POL. Thank you for listening. Do you have any questions or comments?
Chloe?
Do
Do you want
you
to go
wanna
first?
go first?
Sure. Can you go back to your slide of your oblique sketch, please? And here you talk about the 90-degree angle.
Yes.
Can you let me know which two dimensions are the ones that form that 90-degree angle?
Well, you see, I'll use the shape for example. If you look right here, there's a 90-degree angle right here. There's the height and the width of the shape that forms this 90-degree angle, and it's also the pattern of the paper. That's graph paper, and if you draw straight lines, then it forms a 90-degree angle for each shape.
Perfect. Thank you very much.
Julie, this is just a clarifying question. Could you go back to your evidence?
Which one?
I'll stop you. You can go back again. One more. So, and you might have said this, but I just want to clarify. So what was the process that you went through in order to start using stronger examples and not examples? Like how did you find, or so can you go to the next slide? So how did you get here?
Well, I realized that in because this word is in chapter 2, and in my chapter 1 words, I put examples that didn't really make sense, and they didn't really help me remember, and one of the words had more than one definition, and I put a different definition, which really threw me off when I was studying for the exam. But I wanted to improve upon this, so as you can see, for the word warped, the definition was to bend or twist out of shape or to distort something. And I use a distorted photo as an example, and that's very specific, and it helps me remember one of the words so that it's not vague or unclear or anything else, so I can do good on my exam.
Good. Thank you. Thank you, Julia.